Are neutrinos ghosts? Why is it called a ghost particle? Recently, China's Jiangmen Neutrino Laboratory has been very popular in view of the fact that there is relatively little serious science popularization about neutrinos on the internet, and there are a large number of pseudo-popular science videos that confuse the public. As a professional science blogger, I feel the need to popularize science about what neutrino is. Neutrinos are called ghost particles. Some people associate it with a piao. This is actually a misconception. Neutrino is an elementary particle. The reason why it is called ghost particles, because it rarely interacts with other substances. It is this property that allows neutrinos to travel through the Earth virtually unhindered. It is like an invisible ghost that travels unhindered. This stealth property of neutrinos stems from its neutral charge and extremely small mass. Among the four basic acting particles, neutrinos only participate in weak force and gravitational force. Because the range of action of the weak force is extremely small, the influence of gravity on it is also very weak. Therefore, neutrinos hardly interact with matter. That's why it's called a ghost particle, because it can pass through us silently and imperceptibly. Can neutrinos exceed the speed of light? The answer is no. Since neutrinos have a resting mass, according to the theory of relativity, no particle with a resting mass can reach or exceed the speed of light. In 2011, when the European Nunium measured the velocity of neutrinos, there was also an oolong. At that time, they claimed that neutrinos were faster than the speed of light. Just when everyone thought the edifice of physics collapsed in 2011, finally the scientists got the corrected experimental results. That is, neutrinos are slightly slower than the speed of light. Neutrinos are usually produced by weak forces, for example in the process of mutual conversion of protons and neutrons. When one of the upper quarks of a proton is converted into a lower quark, the proton becomes a neutron. This transformation releases neutrinos. Whether it is stellar nuclear fusion or radioactive decay, neutrinos play an important role. In particle physics, neutrinos are only left-handed. That is to say that its spin is in the opposite direction of motion, while antineutrinos are only right-handed, a phenomenon closely related to the Higgs mechanism. The Higgs mechanism imparts mass to particles by flipping them. But because neutrinos don't have chiral symmetry, the source of their mass has become an unsolved mystery in physics. Scientists speculate that the mass of neutrinos may come from neutrino oscillations. That is, neutrinos are constantly changing between different types. This shows that it has a tiny mass. Since neutrinos don't participate in electromagnetic forces, they cannot be directly detected. Scientists believe neutrinos may be candidates for hot dark matter. Dark matter is an important substance that is difficult to detect, but affects the structure of the universe. Scientists speculate that dark matter in the universe may contain massive neutrinos. These neutrinos move relatively slowly due to their large mass, conform to the characteristics of cold dark matter. However, more experimental data is needed to confirm this theory.